Hi, welcome back. This is Professor Ridge, and today's lesson, section 4.5, applications using linear programs. Okay, so let's start off a couple definitions. Objective function. So that objective function is the function for the quantity we want to maximize or minimize. So, for instance, if we're doing something we want to figure out an equation for profit based on whatever we're doing, our objective would be to maximize profit. Or if we came up with a cost function, we want to minimize costs. So that's the objective function. And then we have what are called constraints. So you can have constraints or demands of whatever you're operating. So for instance, you may only you're limited to the supplies on hand. So like say you were making something and you needed 5 items to make whatever you're trying to make. So let's say hamburgers, right? We're cooking hamburgers. And say I want to figure out an equation to maximize profit, which would involve selling X number of hamburgers, but I'm limited to the constraint that maybe I only have 100 hamburgers in my freezer. So that would be a constraint or a demand for this operation. Alright, so let's try a couple. Okay, so this is number 8 from the exercise set from the book. So our objective function, G, whatever G is standing for, we want to maximize it or minimize it. G equals 7x plus 8y. And then we have the following constraints. 3x plus 2y is less than or equal to 12. 2y minus x is less than or equal to 4. X is greater than or equal to 0. Y is greater than 0. Now note, these two put you in the first quadrant. Right, x equals 0 is the y-axis, and greater than is to the right, and y is greater than 0 is the x-axis, and greater is putting it up. So x is greater than 0, x is greater than 0 is that way, y is greater than 0, so that would be quadrant 1. Okay, so our first step is to figure out the constraint region. So we're going to graph all these, and like I said, we're in quadrant 1, so I kind of made my graph just looking at quadrant 1. 3x plus 2y is less than or equal to 12. We're going to put in slope-intercept form. Divide by 2. So we're going to start at 6 on the y-axis. Down 3 to the right 2. Down 3 to the right 2. And I'm going to make that a solid line. And we're going to be less than, so that's going down. And remember, we already established where x is greater than 0 is that way, and y is greater than 0 is going up from the... Remember, x-axis is y equals 0, y-axis is x equals 0. So those two together gives me quadrant 1. So far I'd be inside that triangle. Now for the next constraint, we got 2y minus x. So I'm going to add x to both sides. Divide by 2. 1/2 x plus 2. So I start at 2. Slopes up 1 over 2. Up 1 over 2. Now that's nice that it intersected there because what you need to do is find what we call the vertices of this constraint region. See, we're going down. So I have this constraint region. This is polygon, and there's 5 vertices. So I have to. My second step is identify the vertices. Which in this case it's 0, 0. That's the bottom corner. And this one is 4, 0. And then I have 2, 0, 2. And then where the 2 lines meet, that is 2, 3. Now, that was nice that I could read it off. If I didn't tell that that was 2, 3, like it was off a little bit, I would have to do it algebraically by solving the system of equations between those two. And now you're going to plug in all these vertices into the constraint function. So let me put here, note, max or min can only happen, okay, so max or min can only happen at a vertex of the constraint region. So basically I'm just going to plug all these in. So my third step now is plug each into the objective function, which is g. So g is equal to 7 times 0 plus 8 times 0, xy. So that gives you 0. Now we're going to plug 4, 0 in. 7 times 4 plus 8 times 0. That gets me 28. Now we're going to plug in 0, 2. And that gets me 16. Then I'm going to plug in 2, 3. I'll just punch that in my calculator. So that'll be 14 plus 24, which is 14 plus 24, 38. Okay, so now, since we know the max and min can only happen at the vertex, that's why you figure out the vertices are, and then you plug them all in, and then you identify, okay, this one's going to be the max, and that one's going to be the min. Okay, so that's your last. So the maximum, max for G, whatever G is 38 and happens at 2, 3. The min for G is 0 and happens at 0, 0. Okay, so that concludes the lesson for 4.5, linear programming. Go to my math lab and complete the exercises there. I'll see you next time.